For the first time in history, astronomy has a new kind of photographer. Not a human one, but a machine capable of watching the entire sky change, night after night. Welcome back to CosmoQuest 888. If you're fascinated by deep space, future missions, and the technologies that will redefine how we see the universe, subscribe now and stay with me until the end, because what this observatory is about to do will permanently change astronomy. High in the Chilean Andes, at more than 2,600 meters above sea level, a new giant has just opened its eyes, the Vera C. Rubin Observatory. And while its telescope mirror is impressive, its true heart is something even more extraordinary. It is the largest digital camera ever built. This camera is not metaphorically large. It is physically massive, about the size of a small car, measuring roughly 1.6 meters in diameter and nearly 3 meters long. And its resolution is almost impossible to visualize: 3.2 billion pixels. To put that into perspective, a modern 4K television has just over 8 million pixels. A single image from Rubin contains the equivalent of hundreds of 4K screens worth of detail. If you tried to display one full-resolution image at native scale, you would need around 400 Ultra HD televisions, covering an area about the size of a basketball court. But Rubin isn't just about sharp images. It's about speed and time. Every single exposure captures an area of the sky more than 40 times larger than the full moon, and the telescope can reposition itself with astonishing precision, scanning the sky again and again. Thanks to a powerful computing infrastructure, the observatory will process around 20 terabytes of data every night, detecting up to 10 million changes in celestial objects every single evening. So what is Rubin actually designed to do? Over the next 10 years, the observatory will carry out one of the most ambitious projects in the history of astronomy, the Legacy Survey of Space and Time, or LSST. Every 3 to 4 nights, Rubin will scan the entire southern sky. By the end of the survey, every region will have been observed roughly 800 times, creating an ultra-high-resolution time-lapse movie of the universe. Not a snapshot, a living record of cosmic change. This dataset will include information on an estimated 40 billion objects, asteroids in our solar system, stars in the Milky Way, and distant galaxies spread across billions of light years. With this data, astronomers hope to answer some of the most profound questions in modern science. One of those questions is the nature of dark matter and dark energy. We know that visible matter, stars, planets, gas, makes up only a small fraction of the universe. The rest is dominated by invisible components that shape cosmic structure and drive the universe's expansion. By mapping how galaxies are distributed and how they move over time, Rubin will help refine our understanding of these mysterious forces, working alongside other missions like Euclid. But Rubin's strength is not just depth, it's time. This observatory is a master of time-domain astronomy, the study of objects that change, exploding stars, stellar collisions, matter falling into supermassive black holes, and sudden flares from distant galaxies. All of these events unfold on timescales that traditional surveys often miss. Rubin will catch them in the act. By observing the sky repeatedly over a decade, astronomers will be able to track how often black holes feed, how rapidly they grow, and how violent these processes were in the young universe. For the first time, we'll be able to reconstruct the history of these extreme cosmic events as a continuous process rather than isolated detections. And then there's planetary defense. In just a few hours of test observations, Rubin already identified thousands of asteroids, including more than 2,000 previously unknown objects. Among them were several near-Earth asteroids, none dangerous, but all valuable data points. According to members of the Rubin team, it took 200 years to discover the asteroids we know today. With Rubin, that number could double in just a few months. Over time, the observatory is expected to increase the catalog of known asteroids from around 1 million to as many as 5 million. That means earlier warnings, better orbit predictions, and a clearer picture of what moves through our cosmic neighborhood. And there's another intriguing possibility. Some astronomers hope that Rubin may finally help solve the mystery of Planet 9, a hypothetical massive planet lurking far beyond Neptune. Its existence has been inferred from the strange clustering of distant objects, but it has never been directly observed. If it's out there, slowly drifting against the background stars, Rubin may be our best chance yet to find it. Now, let's talk about the images. Even though Rubin's full scientific operations will begin later, the first test images have already stunned astronomers. In just 10 hours, the observatory captured razor-sharp views of millions of stars and galaxies, along with thousands of solar system objects. One especially breathtaking image focuses on the Virgo cluster, located about 50 million light-years away. This isn't a single photo, it's a composite of more than 1/100 individual exposures, totaling 3 trillion pixels. The final image covers an area around 70 times larger than the full moon and reveals nearly 10 million galaxies. And yet, astonishingly, that's just 0.05% of the galaxies Rubin will observe over its lifetime. Zooming into small sections of this image reveals dramatic scenes. Galaxies in the process of merging, spiral arms torn apart by gravity, and distant reddish galaxies whose color reveals their extreme distance through cosmic redshift. In another image, Rubin captured the Lagoon Nebula and the Trifid Nebula, glowing clouds of gas and dust located about 5,200 light-years away. This image was created by combining nearly 680 exposures over 7 hours, revealing faint structures and young stars in stunning detail. To an untrained eye, these pictures may look similar to images from other telescopes. But the real power of Rubin lies beyond what our screens can show. Most displays simply cannot render the full resolution of these images. The science is in the data, hidden in the pixels, motion, and change over time. And scientists are already using that data. Even during early testing, researchers identified thousands of new asteroids and refined measurements of known objects. This is just a preview of what's coming. So what does all of this mean? It means we are entering a new era. One where astronomy is no longer just about looking deeper, but about watching the universe evolve. Rubin will not only show us what the cosmos looks like, it will show us how it behaves, how it changes, and how often the unexpected happens. Every generation builds tools that redefine its place in the universe. The Vera C. Rubin Observatory is one of those tools, and this is only the beginning. If you want more deep dives into future missions, extreme technologies, and the discoveries that will reshape our understanding of space, subscribe to CosmoQuest 888. You can also add our videos to your YouTube tabs so you never miss a new episode. In the next video, we'll explore how Rubin's data could change our understanding of dark energy, or how it might uncover entirely new cosmic mysteries. Until then, keep looking up and keep questioning what you think you know about the universe.